Okay, in this video we're going to start our explanation of formal logic. And formal logic is important on the test. It's important to understand because it comes up on several of the questions that you're going to encounter in the argument section. So here we'll start our explanation of the concepts involved, the qualifiers that are the basis for formal logic, and specifically in this video we're going to talk about the all qualifier and the some are not qualifier. Okay, so let's take a look at this argument we have here. It says, all people are mammals, and some people are lawyers. No sharks are mammals, therefore no lawyers are sharks. Okay, so we're using that just to illustrate these qualifiers, and it's a true argument, by the way. And so this is an example of a formal logic argument. Now these arguments have a specific vocabulary and a specific structure, and like I mentioned, they don't appear very often, but in order to do them, you need to use a specific approach. And so this is the vocabulary that I was talking about. So here on the left, you have the 6 qualifiers that are really important. All, most, some are not, most are not, and none. And these arguments, these formal logic arguments, involve these qualifiers that relate two things, two ideas, or two concepts. So these qualifiers on the right, on the left, are going to relate these two things. Now, the questions will require deductions from the given information. And this requires an understanding of these qualifiers and of how to represent that information. So this argument here talks about people, mammals, lawyers, and sharks. And as you can see, those different concepts are all related using the qualifiers all, none, and some. And the conclusion depends on the deduction based on those relationships in these premises. Okay, so let's take a closer look at one of the qualifiers, all. So we have here a statement, all dogs are animals. So, all means everyone or everything. And this is that every element in the first group is part of the second group. And this is a standard everyday meaning. So we have here that bar on the right, the percent bar, and we see that all corresponds to 100%. It's your basic intuitive understanding of all. Okay, so this premise, the all dogs are animals, it simply lets you know that every dog is also an animal. So Sparky is a dog, so you know that Sparky is an animal. Bingo is a dog, so Bingo is an animal. Rover is a dog, so Rover is an animal, etc., etc. Whenever you have something that you know is a dog, you also know that it's an animal. And like I said, you can think of this qualifier as saying 100%. When you see all, think 100%. So 100% of dogs are animals. Now, and this is very important, what's the negative of this statement? So we have here it says all dogs are animals. How would we negate this statement? The way you negate it is by saying some dogs aren't animals. So this is very important. Some are not is the negative of all, and vice versa. The negative of some are not is all. And in order to do these questions that use formal logic, you have to know how to take the negative of the premise, and you have to memorize that for this qualifier for all, some are not is the negative. And the reason I keep stressing that that's important to remember that some are not is the negative of all is because people initially think that the negative of all is none. And that's actually not the case. We can think of that as maybe the opposite of all, but it's not the negative. And you'll see why as we explain further. So, let's take a look at this statement. It says, some animals aren't pets. Now, some are not means at least one isn't, and possibly none are. So there's at least one element in the first group that isn't part of the second group. That's what some are not means. It means that there's at least one element in the first group that isn't part of the second group. Now this is different from the everyday meaning because it includes none. When we say some aren't in everyday conversation, we generally don't mean to include that it could also be that none aren't. But in the LSAT, it could also include none. So, taking a look at this premise, it simply lets you know that there are animals that aren't pets. But you have to be careful, unlike in everyday usage of some aren't, that doesn't imply that there are some animals that are pets. When you see a premise with the qualifier some aren't, keep in mind that it doesn't have to mean that some are. So some aren't does not have to imply that some are. Now, thinking of it in terms of percents, this qualifier can mean everything under 100% up to and including 0%. We include that 0% because some aren't can also mean none. This is what I keep stressing. So some animals aren't pets can mean that no animals are pets. And if we look a little bit closer at our graph here on the right, we see that some are not encompasses everything below 100%, including the 0% bar. Okay, so let's take a look at our initial premise, all dogs are animals. Now, can we reverse that? We say that all dogs are animals, but does that mean that all animals are dogs? So are all animals dogs, according to our definition of what all means, that it means 100%? No. This qualifier is not reversible. So whenever you see all, you know that you can't simply reverse the two concepts. So if a premise says all A are B, you cannot automatically assume that all B are A. Now, it's important to know whether the qualifiers are reversible, because that's additional information to work with, and having you assume that a premise is reversible is a common trick to fool you with these questions. Now let's take a look at the second premise. Some animals aren't pets. Can we reverse that? Can we say that, is it true that some pets aren't animals? Once again, no, this qualifier is not reversible either. If a premise says that some A are not B, you can't automatically assume that some B are not A. And that's something that we know from the virtue of these statements. If all dogs are animals, we all know that all animals aren't dogs. There are different kinds of animals, and not all of them are dog. And likewise, with some animals aren't pets, we can't say that some pets aren't animals. Okay. And in terms of representing or presenting these premises, they're best presented visually. So for the all qualifier, the circle representing the first part has to be completely inside the circle representing the second part. Now, they may also overlap completely so that no part of one circle is not part of the other, but the point is that the circle representing the first part has to be completely inside the circle representing the second part, whether or not that the circle representing the second part has something that's not a part of the first circle. So as we see here with the animals and the dogs, we see that dogs is completely inside animals. For the some are not qualifier, the circle representing the first part has to have part of it outside the circle representing the second part. Now they may be completely separate. And in this case, we have the circle representing animals having part of it outside of the circle representing pets. So, once again, these two representations are examples of how you should represent the premises in the formal logic questions. You should use circles. The first two circles represent the first premise, and the other pair represent the second premise. And like I mentioned, there are other ways we could have drawn the circles. The animal circle and the dog circle could have completely overlapped, and the animals and the pet circles could have been completely separate. When you're diagramming arguments, you should reuse circles. So the same argument can be represented with different diagrams, and you should be careful not to assume that something has to be true. So we have these representations here that are different representations of how we could have represented this argument. There are two different ways. The group of circles on the left combine the two groups of circles that we previously put up, and that diagram tells us that there are some animals that aren't dogs, and there are some dogs that aren't pets. And we can say that because if we look at the animal circle, we see that part of it is not within the dog circle. So whichever animals fall outside of the dog circle aren't dogs. And likewise with the dogs and pets circles, we see a part of the dog circle is not in the pet circle. So that means whichever dogs are part of the dog circle that is not overlapped with the pet circle, those dogs aren't pets. The group of circles on the right is another equally valid way of representing the two premises, and the additional info that we get from the diagram is that all animals are dogs, and that's because we have the animals in the dog circles completely overlap, so whichever animals are in the animal circle are all going to be in the dog circle. And we also get that no animals and no dogs are pets. That's because the animal circle is completely separate from the pet circle, and the dog circle is completely separate from the pet circle. Now, given what the qualifiers all and some are not mean, These are perfectly reasonable deductions because the way we've represented them using these circles completely capture their definitions. Now, in real life, obviously, it's not the case, but it's consistent with the definition of these qualifiers, and that's important to know because that's going to be important when you do the actual arguments. The important thing here to remember is that there are different ways of diagramming an argument. Okay, so to recap, the qualifier all means 100%, and some are not means anything less than 100%. They're each other's negatives, and they're not reversible. That's also very important to keep in mind. All A or B does not mean that you can conclude, that you can deduce that all B are A. For all, the first circle has to be completely inside the second. That's how you need to represent it. And that can also mean that the two circles can overlap. That's what being completely inside, it can also mean that. And for some or not, the first circle has to have a part of it outside the second. Once again, that could also mean that the first circle is completely outside the second. When you're making diagrams, reuse the circles and be careful with your assumptions.